All right, section 4.5, we're going to look at simplifying algebraic fractions. All right, we'll start with simplifying fractions using GCF, and then we'll get into simplifying algebraic fractions. First off, some key terms. Simplest form of a fraction, it's when the GCF of the numerator and denominator is 1. For example, if I have the fraction 3 over 6, this is not in simplest form because the GCF is greater than 1, right? The GCF is 3. So that would be the same as 1/2. This is simplest form. An algebraic fraction is a fraction that contains a variable in the numerator and or denominator. All right, so let's look at equivalent fractions on a clock, just so we can kind of see what simplest form would be. For example, if I divide the clock into minutes, right, it would be divided into 60 equal sections, right? And then if I look at this slice here, right, and I were to count up the minutes, right, and I'll show you what I mean, just little slices there. All right, and I'm getting bad, so I'm gonna stop. There would be 15 of them, right? There's 15 minutes there. Now, this is not in simplest form, all right? But we can also look at this in terms of hours, right? So if I look at a clock and start with the total, right, it's divided into 12 hours. If I look at that same section, I can see that, right, it's can be divided up into 3 hours, right? So these two are equivalent. Still not simplest form, right? If I were to just take this and divide it here, right, there are 1, 2, 3, 4 equal sections there, and we are looking at 1/4 of that. So what we're going to be looking at today is how do we get from here to here, right? How do we take this fraction and get it to simplified form? And there's a few ways that we're going to look at doing that, and you can decide which one works best for you, right? Sometimes you'll be able to look at it and you could say, well, I know that 15 goes into both of these, right? And you can jump from here all the way to here. Or you might say, well, I know 5 goes into both of them, right? So if I divide that by 5, I get 3. Divide that by 5, and I get 12. And then I notice, oh, well, these are both divisible by 3, right? 3 divided by 3 is 1. 12 divided by 3 is 4. And we'll also look at a method using prime factorization in a cancellation method to help us get from here over to the simplified form of the fraction, where the GCF between these two is just 1. All right, so let's look at a few examples. All right, let's start with number 1. And I can look and I can say, I want to find a number that goes into both of these, right? And I know that 3 goes into both of them, right? So I could write that top is 3 times 2, right? That still totals 6. And on the bottom, I said that 3 went in there. And I know that 3 goes in there 13 times. We should also know that 3 over 3 is equal to 1. So when I cancel those out, the simplified fraction is 2 over 13. There's no other common factor between these two other than 1. Right? I might say, okay, 9, I know 9 goes into 36, right? So I can just divide the top by 9 and the bottom by 9. Right? 9 divided by 9 is 1. 36 divided by 9 is 4. Greatest common factor between these two is 1. Now, getting into larger numbers, we can look at using our prime factorization, right? Meaning I'm going to take 64 here, and I'm going to write that, start out as 2 times 32, right? 2 is prime, so that stays. 32, I'm going to say that that's 4 times 8, right? 4 can be broken down into 2 times 2. 8 can be broken down into 2 times 4. So 64 is really 2 times 2 times 2 times 2, right? And then that 4 would be 2 times 2. So there's my 64. 80, right? If we break that down, I could say, okay, well, that's 2 times 40, right? And then I'm going to say that that's 4 times 10. And so we'd have 2 times 2. Here we would have 2 times 5, all primes. So I'm going to take that here and I'm going to write it out underneath it. So 2 times 2 times 2 times 2, right? There's 4 of them, and then there's times 5. So every pair, top and bottom, I can cancel out. Now, looking what's left over on top, we have 4. What's left over on bottom, we have 5. So we have 4/5 is the simplified form of that. So you can see that you can use prime factorization and just cancel out. You can look and see, do you have a GCF, right? And you might get there in steps. You might say, okay, well, I know that 96 can be divided by 2, and so can 108, right? And if I divide 96 by 2, should get 48. And if I divide 108 by 2, I should get 54. Now, I should know that this is not simplified because they're still both even. So I could, again, go divide by 2. Right, 48 divided by 2, I get 24. 54 divided by 2, I get 27. And I can say, oh, well, I can still keep going here because I know that 3 goes into this and 3 goes into this. So 24 divided by 3 would be 8, and 27 divided by 3 would be 9. So that should reduce to 8 over 9. So look what we did. We've divided by a factor of 2, 2, and 3, right? So if I wanted to do that in one step, or if I wanted to know, like, what was the greatest common factor there, right? 2 times 2 is 4. 4 times 3 is 12. So if I would have just started here by dividing both of them by 12, I would have jumped right to this fraction, the simplified fraction, right? So if you know the GCF right off the bat, go for it. That'll shorten your time on the problem. But if not, you can do it in steps, or you can do the prime factorization and then essentially cancel out the common factors. Now, this last one here, 14 and 29, right? I'm going to do prime factorization, right? I know 14 would be 2 times 7. And I know 29 is a prime number. So 29 is only going to have 1 times 29 as factors. So these are all prime. So here's my prime factorization. This is already in simplest form. So on a problem like that, we would just write simplified. That one is already simplified. There's nothing else to do for that problem. All right, take a minute and pause here and see if you can simplify number 1, 2, and 3 using whatever method you choose. So pause here and try them. All right, go ahead and check your work there. For number 1, should be 8 over 17. And the GCF there at the beginning, excuse me, I messed that up. The GCF should have been 8, so that would have been 4 over 17. So you could have divided by 4, divided by 4. Nope, sorry, I'm getting those backwards. 32 divided by 8 is 4. 136 divided by 8 should be 17. So 4 over 17 should be the simplified answer for that. This one here, both of them were divisible by 5. 85 divided by 5 is 17. And 100 divided by 5 is 20. And then the last one, number 3, that is already in simplified form, right? 17 is a prime, so that would be 1 and 17, and that does not divide into 56. So 1 is the GCF, which means it's in simplified form. All right, simplifying algebraic expressions, right? So we know how to simplify the number part of it. For the variable part, right, we can expand. So here, 8 to the 7th, 1, 2. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4. So as I cancel out, these are all equal to 1, right? So I end up with, right, 1 times 1 times 1 times 1 on the bottom would be 1. And on the top, I have a to the third. You could write that as a to the third over 1 if you want to write it as a fraction, but an answer key would have it like that, right? Usually divide by 1, we don't write that there. However, have to be careful, like on the next one here, x to the third would be x times x times x. And then we'd have 1, 2, 3, 4, 5, 6, 7 on the bottom. So if I cancel, right, so they all cancel from the top, right? They're equal to 1, and I have 4 left over on the bottom. So I have to write that one as 1, and then x to the fourth. So if there's nothing left over on top, meaning they all canceled out, and each of them, right, x over x is equal to 1, so it'd be 1 times 1 times 1, right, which leaves me with a 1 on top. And then I have x to the fourth on the bottom. All right, so number 3, 2 variables, same thing, right? So we can go e times e, f times f, and then the bottom there's 3 e's and 1 f, right? I can only cancel variables that are alike, right? Meaning e over e is equal to 1, right? E over e equals 1, and f over f equals 1. So I'm left with an f on the top in the numerator, right, and an e on the bottom in the denominator. Cannot cancel those out. Those are different variables. So here, remember we talked about the number part of it, right? So if I want to simplify 2 over 10, I know that 2 divides into both of them, right? 2 divided by 2 is just 1. 10 divided by 2 is 5. Now if I expand out the variables, so that'd be a times a times a, and then b times b times b times b, right? 4 of them there. Down here we have a to the fifth. And then b to the first. So I can cancel 3 of the a's and 1 of the b's. So now I have to figure out what's left over. So on top I have 1 and times b to the third. Right, now I could write that 1 here if I wanted to, but Remember, a coefficient of 1 doesn't need to be written. And then I have on the bottom 5, and then there's 2 a's left over, so a squared. And then example 5 here, right? M squared p to the third. There is no like terms on top and bottom, so that is simplified. All right, your practice for today is on page 172. And you can do the following numbers: 20 to 27, 30 to 42 even, and 54 to 58. If you have questions, please join me at one of my Google Meet times or email me and we can set up a way to get your questions answered. Have a great day.